For the first video in the series, I'm going to walk you through the first, looks like 8 problems of section 3.9. These are going to be using, looks like mainly our exponential rules. And so we need to keep in mind that the derivative of e to the x is simply e to the x, or in this case, we will be doing some chain rule problems, so more appropriate for us to say that the derivative of e to the u, again, the derivative of that is simply e to the u, but then we need to account for the chain rule, and we get du dx. So for number 3, this is a chain rule problem. The outer function is the exponential, the e. The inner function is simply negative x. So that means when we take the derivative, we get the derivative e to anything is going to be e to that thing. And then we multiply by the derivative of the inside, which the inside in this case is the power, negative x. And the derivative at negative x is negative 1. So the answer to this question is simply going to be negative e to the negative x. And that's it. Pardon me. So number 6, this for some people looks a lot like a quotient rule problem, but it's a little bit easier to do if we just rewrite the problem to be y equals e to the negative 1/4 x. And then it's essentially like the previous problem. So once again we have a chain rule. The outer function is the e, and then instead of just being e to the x, we have e to the negative 1/4 x. So that's what makes it a chain rule. So then the derivative will simply be, again, the derivative of the outer function e is e. So it's e to the negative 1/4 x times the derivative of negative 1/4 x, which is simply negative 1/4. So therefore the answer is negative 1/4 e to the negative 1/4 x. So for this next problem, again the derivative, the outer function is e, so it's e to the square root of x, and then we have to multiply by the derivative of the square root of x, so that's 1/2 x to the negative 1/2. And I'm not really too worried about simplifying this one. Let's just put a box on it and move on. So as we look at number 12, it looks pretty basic. I think some of us are going to try and apply one of the new rules, but if you look carefully, it's simply the x to a power. This is simply like x squared, except instead of something nice and simple as squared, it's a weird power, but notice it is just a constant power. So this is just the power rule. Not really sure why they snuck this one in on us, other than maybe just to test, make sure we're paying attention. So the derivative of x to the n, we bring the power down, so the power is simply 1 plus the square root of 2, x to the, and then we subtract 1 from the power, and when we do 1 plus the square root of 2 minus 1, we're simply left with the square root of 2. And that's not a chain rule or anything, because that's just a constant. It's just the square root of 2, not the square root of x. Okay, so now we have a new rule to use. We have the y equals a to the x rule, which is really similar to the e to the x. So let's restate that rule. The derivative of y equals a to the, let's do it as a chain rule, u. Simply going to be, the derivative is going to be just like e to the x, it's going to be exactly like it's stated, but there's also a natural log of a. And then we have to do the chain rule, so times du dx. So again, the derivative of the a part is a to the u natural log of a. That's all the derivative of a. And then we have to do the chain rule the derivative of du dx. Alright, so this one is a pretty straightforward problem. There is no chain rule. So the derivative of 8 to the x is 8 to the x times the natural log of 8. And that's it. Problem's done. So problem 18 is very similar to that, except this time we do have a chain rule. So the derivative of the outer function is just the 3 to the power. That's going to be 3 to the cotangent of x times the natural log of 3. So that's all just the derivative of the 3 to a power. And now we have to do the chain rule. And the derivative the derivative of cotangent is going to be the derivative of tangent is secant squared, so the derivative of cotangent is going to be, I'm going to put it in parentheses so it doesn't look like I'm subtracting, negative cosecant squared of x. And we could simplify a little. Let's at least pull the negative to the front. That's about really all I care about. So negative, there's really no hard and fast rule on this. I'll throw the natural log of 3 first times cosecant squared of x times 3 to the cotangent of x. And the last of these problems look like they're both natural log problems. So let's drop down here. Let's get a little messy on the page. And let's review the natural log of u. So let's build a chain rule into it. The derivative would simply be 1 over u. And that's the natural log. And then the chain rule is du dx. And I just realized I put that right over where I'm going to need to do the work on 24, so I'll erase that in a minute. So the derivative of 21 is going to be y prime equals chain rule. The outer function is natural log, so the derivative natural log of anything is going to be 1 over that thing. And that's it for the outer function. And then we need to take the derivative of the inside function, which is simply 2x. And I hope that you can see that we could simplify that down. We have x on top and x on the bottom. So that's going to simplify down to 2 over x. And that's our derivative. Alright, let me erase. Whoa. Let's undo that mark. And now let's erase. And that shouldn't have happened. Alright, I guess maybe we should just call this a video and alright, there we go. Alright, sorry about that little hiccup. Alright, let's get back to this. So 10 over x, I think it'd be easier to do as the natural log of 10 x to the negative 1. I think that would be easier to solve so that I don't have to do a quotient rule. Possibly we might run into some problems, but let's just see where it takes us. So the derivative of the natural log is going to be 1 over whatever's inside of natural log. So that's it. And then times the derivative of the inside, which is going to be a power rule. So the negative 1 comes down, gives me negative 10 x to the negative 2. Clean this up a little bit. We're going to have to squeeze it in. Sorry about that. X to the negative 1 on the bottom means move to the top. So that becomes x over 10 times, we've got our negative, we've got our 10, and then the x to the negative 2 goes to the denominator. And so simplifying, 1x cancels, I've got my negative, my 10's cancel, so it looks like the answer is 1 over x. And I think that will conclude this. And stay tuned for the second half.